Greetings, I am William Shakespeare. This is the AI Debates. Human inquiry often seeks whether natural events unfold by necessity or admit fundamental irregularity. Today's discussion asks, is the universe deterministic? The thinkers are Max Planck and Isaac Newton.
My central claim is that nature follows universal laws, yet these laws reveal a structure not wholly captured by the idea of smooth continuity. Careful study of radiant heat showed that energy cannot be exchanged in arbitrary amounts. Instead, it appears only in definite portions. A quantum is the smallest unit of energy transfer. This discovery does not abolish lawfulness. It deepens it. The distribution of energy in thermal radiation obeys a precise mathematical rule, confirmed by experiment. The constant h fixes the size of these energy portions. The law remains strict and objective, but the underlying processes occur in discrete steps. Determinism, therefore, must be reconsidered. Classical reasoning assumes that every physical change can be divided endlessly. Evidence from radiation contradicts this assumption. Nature's order may be lawful, yet fundamentally granular, not infinitely divisible.
My central claim is that the universe operates according to exact laws determining motion from known conditions. If the forces acting on a body and its present state are known, its future motion follows by necessary calculation. Consider a planet moving around the Sun. Its path results from the force of gravitation acting upon its mass. The same rule applies to falling stones and the tides. These phenomena differ in appearance, yet obey a single, measurable relation. A force is a cause that changes motion according to rule. Determinism follows from this structure. Motion arises from forces acting in space and time, both existing independently of observers. When the governing quantities are known, the outcome is fixed by mathematical law.
Newton claims that knowledge of forces in present conditions fixes future motion completely. This reasoning assumes that physical change varies continuously. The evidence from thermal radiation contradicts this assumption. Measurements show that energy exchange between matter and radiation occurs only in definite portions. If energy could vary smoothly, the predicted distribution of radiant heat would diverge from observation. My radiation law fits the data only when energy is restricted to finite units determined by the constant h. Therefore, the difficulty lies not with lawfulness, but with the classical assumption of infinite divisibility.
Planck argues that energy is exchanged in fixed portions and suggests this challenges classical reasoning. Yet a mathematical law describing radiation does not overturn the general principle that motion follows causes. A discrete quantity does not remove determinism. If the size of each portion is known, the resulting changes can still be calculated exactly. The presence of steps rather than continuous variation alters the form of calculation, not the necessity of outcomes. Thus, the essential question remains unchanged, whether physical events follow rules sufficient to determine their consequences.
If nature proceeds through discrete steps rather than continuous change, does this alter whether future events follow inevitably from present conditions?
My answer is that discrete structure changes the foundation of physical explanation. Classical physics assumes that quantities may vary by arbitrarily small amounts. Radiation experiments show that this assumption fails at fundamental scales. The constant h fixes the minimal unit of action linking energy and time. Because processes occur through such indivisible units, the traditional mechanical picture becomes incomplete. Determinism may still exist in mathematical law, yet the path connecting present conditions to future outcomes is no longer described by smooth classical motion.
My answer is that the existence of discrete units does not remove necessity. Determinism requires only that events follow definite rules connecting cause and effect. Suppose a body receives impulses in fixed amounts rather than continuous force. If the magnitude and timing of those impulses are known, the resulting motion remains calculable. The law governing change still determines the outcome. Therefore, the decisive matter is not continuity, but the existence of consistent relations between quantities.
My conclusion is that nature's order is real but more subtle than classical mechanics assumed. Radiation experiments forced recognition that energy exchange occurs in discrete units fixed by a universal constant. This discovery preserves strict law while overturning the belief that physical change is infinitely divisible. Determinism, if it exists, must be framed within this deeper structure of quantized action.
My conclusion is that determinism rests upon universal laws connecting causes with measurable effects. Whether quantities vary continuously or in fixed steps does not change this principle. When forces, masses, and conditions are known, the resulting motion follows necessarily. The strength of natural philosophy lies in discovering these relations and expressing them with exact calculation.
The discussion has explored whether the universe unfolds by strict necessity, or whether newly discovered structures alter that certainty. Classical motion and quantized action reveal different views of nature's order. Their tension remains unresolved. This has been the AI Debates.